All right, what we've been doing so far is calculating the margin of error and doing a comparison. Well, what if we wanted to do a more formal statistical test? What? Oops. All right, what if we want to do a more formal statistical test? In the previous scripts, in the previous videos, we calculated the upper and lower bounds for the using the margin of error. And the means. And we also and we used the confidence interval using a bootstrap technique. Okay? Maybe your stats professors will look at the accountant teaching Python and go, "What the hell is he talking about?" It doesn't matter, right? It's it gives you a pretty good idea that these two stores may be different. All right. So, and when we did this, we could evaluate whether there was any overlap between the ranges we calculated. And we concluded that one store had higher daily sales than the other. Right? Well, if you call back to your statistics course, you may remember what's called a t-test. And we can execute a t-test using Python and a lot of other tools as well, right? So this is not just Python only. All right. So let's do all the fun things we like to do, right? So let's put in our cell, import pandas as PD. Let's import SciPy as stats. Let's import NumPy as NP. Let's get our data frame. We want to pd.read underscore CSV sales final. Whoops. Make sure you get the right title. Final 6/30/2021.csv. And I want to change the sale date equals PD to date time, and we want DF sales date. Okay, let's run all that stuff, get that all done, get that being read in. Repetition's not a bad thing, folks. I do it a lot, and that's how I start to remember some of these things. So you may look at this and go, why does he keep on rerunning that script, retyping it every single time? I like doing that. It builds mind memory. All right, so let's continue. to use the sales file from June 2021 and evaluate the sales transactions. All right, so first we want to, let's start a new cell here. I'm going to create DF34, and that's going to be DF query, where store equals 34, and I'm going to create DF76, where DF query and store equals 76, right? So I can create those two queries. And now what I'm going to do is I'm going to put in my SciPy stats. So stats dot mstats dot test underscore ind. All right. Remember, I brought this in as stats. So I'm doing, there's a thing within SciPy. So it's called mstats, and there's a t-test, and we're looking at independent, right? So store 34 and 76 are theoretically independent. So we're going to put in, we're doing a test of DF34, specifically sales dollars, against DF76 sales dollars. And we're going to make an assumption that they have equal variation. Okay? And if we could go back and take a look at their standard deviations, they're probably not that far away from each other. They probably have similar variance. Okay? So this is it. This is the line to do a t-test, and we're doing a t-test between these two variables. So I'm going to run this whole cell. Hopefully it works out. Nope, did not like that. So has no. All right, so let's try SciPy.stats. Let's try that. SciPy.stats.mstats.test. That should work. Let's try it again. And maybe what I'll do is I'll just read SciPy, import SciPy, not as anything. Okay. Now let's try it. It does not like that. All right, I'm going to have to go in here and see what I've got that is incorrect. Okay. Hold on one sec. Okay, I figured out what was going on, and so what I did is I went to scipy.org, I went to the introduction, and one of the things that I forgot to do, I obviously brought in SciPy, but there's also some sub packages that need to be imported separately. So I needed to import this stats package separately. So from SciPy, I need to import stats, and there's a number of different stat packages that exist in here. Optimize, if you're trying to optimize different kinds of things or finding routines, linear algebra, input output, lots of different sub packages. So the thing that I added to this script was I added this line here from SciPy import stats. I had written this out correctly, scipy.stats.mstats.test, but I forgot to do that piece. So when I run this again, right, so I'm going to run this whole cell. When I run this whole cell, it's going to give me the, hopefully soon, give me the individual stats. I guess I need to have it put somewhere or run this one line separately. Let's run this one line separately. Oh, here we go. Here's my output for it. So if I would have probably had to assign it to something. So the t-test individual result, the statistic is 19. All right. Okay. Well, what does that mean? Well, The higher the t-statistic, the more likely they are different. And the p-value here is, if you recall back to your stats, the probability that these two things are not the same, right? Or the probability that what you are predicting is not true. And here it's 0.00 to the negative 81st power. So it's a high unlikely, very high unlikelihood that these two populations are significantly different from each other. Okay? Highly unlikely. So here we are. All this is a t-test of means, and we've very quickly been able to determine that these two things are very different from each other. All right? So what if, and let me put some language around this so you have this in your notes. In this case, the very large t-stat 19.05 and the very small probability, and that's 5.9 to the minus 81st power, right? Suggest that these mean sales amounts between the two stores are different, and that there's a very low probability that they aren't. What if we wanted to aggregate daily sales? Okay, because remember, all we did is we've got this data frame with two data frames, one with 423, both of them have around 423,000 observations. Well, what if I make that smaller and do an aggregation of the sales dollars, but we'll group them by sales date? Okay, so let's try that. Give myself some room here. All right. Let's give it a try. And I know this is the last thing on. No, it's not the last thing on this test. Okay. I think we'll hold this off to a part 2 video. I don't want to make these things too big.